Alright, let's look at the homework 3.4, problem number 5. Alright, a rectangular page to contain 98 square inches of print. Margin at the top and bottom is 2 inches wide, and the margins on each side is 1 inches wide. Alright, so we want to find a dimension that will minimize the amount of paper used. Alright, so let's do that. Alright. Let's see. So we know that, let's see. So you have this is X, right? And here, this is Y. So the print is going to be, so we have X, but you have to take away 1 inch from both sides. So you subtract 2. All right, and then Y, you have to take out, let's see, 4 inches from the height. So this has to be equal to 98. Right? So if you multiply this out, we're going to get, let's see, xy. And so I'm just distributing x to y and 4 to get, let's see, negative 4x. Right? And then distribute the negative 2 to y and negative 4. We get negative 2y and plus 8. And this is equal to 98. Right? So I'm going to move, let's see, I'm going to solve this equation for y. So I'm going to move this guy over to the other side, and here, move this side, negative 4x over to the other side. So what you get is going to be, so I have to add 4x and subtract 8, right? So what you get is two terms, xy and the negative 2y combined would be x minus 2y. I just pulled the y out. And then we are adding 4x. We have a 4x. And 98 minus 8 would be 90. So 4x, so 90. Right? Then I can just divide through by x minus 2 to get y. So y is going to be 4x plus 90 over x minus 2. Right? So that's y. Right? Then the area is going to be, let's see, x times y, right? So base times height. But in this case, y is 4x plus 90 over x minus 2. So you're going to get 4x squared plus 90x and over x minus 2. Right? So we want to minimize this function here. Right? So let's look for the critical number. So a prime, so we can think of this as a function of x now. So we have a prime of x is equal to, right? So let's use the quotient rule, right? Square the bottom, x minus 2 squared. Right, derivative of the top is 8x and plus 90, right? Times the denominator, so which is x minus 2, right? Minus we have 4x squared plus 90, so that's the top guy, and times the derivative of the bottom, which is just going to be 1. Right? So if you simplify that, you're going to get, let's see. Right, so 8x times x is 8x squared, and 8x times negative 2 is negative 16x. And then you have a 90x, and then you have a minus 180. Right? Then you're subtracting 4x squared and the 90x. Then denominator stays the same, quantity x minus 2 squared. Right? So we can cancel 90x here minus 90x. And then combine 8x squared and a negative 4x squared. We're going to get positive 4x squared. And then x term would be just a negative 16x, so negative 16x. And then we're going to have, let's see, 180, so negative 180. All right, so negative 180 over quantity x minus 2 squared. All right, so it seems like 4 is in common. I'm going to pull 4 out from the numerator. So we get x squared minus 4x minus, so divide by 4, so it's going to be 4 and 16, so 20, so it's going to be 45. And x minus 2 squared. All right, so if you set this guy equal to 0, all you have to do is solve this quadratic equation. So you have x squared minus 4x minus 45, right? And this is equal to 0. And if you factor this out, this can be factored out as x plus 5 and x minus 9. Right, so that's equal to 0. Right, so that's going to give us a critical number, x equals negative 5 and a positive 9. Right, you can see that since we're talking about x as a length, so we cannot really take a negative value, so negative 5 is out of the way. So we have one critical number, which is 9. Right, so let's make sure that we're going to get the minimum value there by looking at the interval here. All right, x is let's see, at least let's see 2, right? Because you have 2 inches of margin, so you have starting from 2. All right, and critical number is 9. All right, so let's look at the sign of the derivative here. So we can try anything between 2 and 9. So I'm going to try 3 maybe. So a prime of 3. Right? So if you plug in 3, you can see that this guy is going to be negative. This is positive. So this is negative. So we know that the derivative is negative. Right? And after 9, so we can try plug in 10. So you can see that 10 plus 5 is positive, 10 minus 9 is positive, so everything is positive. So the derivative is positive. Right? So we know that area function A is decreasing between 2 and 9. And after that, it seems it's always increasing there. Right? So we know that here, this is going to be, right here, is going to be the minimum value, right? Actually, it cannot be equal to 2, so maybe I have to eliminate that. So 2, so I'm going to do that. All right. So at 9, x equals 9 would be the minimum area, so x equals 9. And y can be found by just plugging in. So here's the formula. So we have a 4 times 9, so 36 plus 90 over, and 9 minus 2 is 7. So this is going to be, say, 126 over 7, right? So this is going to be 1 and 18, right? So x is 9 and y is 18. So let's type it in, right? X is 9, y should be 18, right? Let's submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.